One of the most captivating cosmic spectacles on the horizon is the anticipated supernova of Betelgeuse. Positioned on the iconic shoulder of the Orion constellation, this deep crimson supergiant is nearing the end of its stellar journey. In late 2019, something extraordinary occurred. Betelgeuse, one of the brightest stars in our night sky, began to dim noticeably, even to the naked eye. Over several months, its brightness declined dramatically, sparking global speculation. Was this the moment we'd all been waiting for? Was Betelgeuse on the brink of exploding into a supernova? Astronomers were astonished. As one of the most studied stars in the sky, Betelgeuse's behavior has long fascinated scientists. But this dimming was unusually extreme, suggesting that the red giant might be entering the final phase of its life. The question now looms larger than ever. When will Betelgeuse explode, and what exactly will trigger it? Betelgeuse, located at Orion the Hunter's upper right shoulder, is also known by its formal designation, Alpha Orionis. Although it's the second brightest star in Orion after the blue supergiant Rigel, Betelgeuse remains the most intriguing due to its variable brightness, deep red hue, and immense size. Interestingly, the name, Betelgeuse, comes from Arabic, loosely translating to the giant's armpit, a reference to its position in the constellation. Despite its quirks, it ranks among the top 10 brightest stars in the night sky and is especially prominent from North America, Europe, and Canada. Betelgeuse is shedding about 1 solar mass every 10,000 years. This ejected material forms a massive nebula extending over 30 astronomical units, roughly 30 times the distance between Earth and the Sun. This cloud is estimated to be 250 times more massive than the star itself. At its core, Betelgeuse is fusing hydrogen into helium under immense gravitational pressure, releasing vast amounts of energy. As hydrogen runs out, the star begins fusing helium, then carbon, then heavier elements like neon, magnesium, and finally iron. But when fusion reaches iron, the process halts. Iron fusion consumes energy rather than releasing it. With no more fuel to counteract gravity, the star collapses inward and eventually detonates as a supernova, one of the most powerful explosions in the universe. Stars emit different colors depending on their temperature and age, ranging from blue for young stars to red for older ones. Betelgeuse's signature reddish glow marks it as a mature star nearing its end. The ancient astronomer Ptolemy described its color as ruddy, but early Chinese astronomers once recorded it as yellow, hinting that Betelgeuse may have previously been a yellow supergiant before evolving into its current state. Massive stars like Betelgeuse burn through their hydrogen rapidly. Though they live fast and die young, lasting only about 10 million years compared to the Sun's 10 billion-year lifespan, they leave a lasting legacy in the cosmos. There's no doubt Betelgeuse is now in its final stage. But the exact timing of its explosion remains one of astronomy's great mysteries. Betelgeuse exhibits two known brightness cycles, one lasting about 5 years and another shorter pulse of roughly 100 days. These cycles, likely due to the expansion and contraction of its outer layers, cause visible fluctuations in size, temperature, and brightness. The massive dip in brightness seen in 2019 and early 2020 drew intense interest and speculation. Some scientists believed the star was transitioning into the final stages of its life. While historic observations of Betelgeuse date back to at least the 1st century BC, its recent behavior has introduced new uncertainties. In addition to dimming, Betelgeuse is moving through space at about 30 km per second, likely after being ejected from its birthplace in the Orion OB1 association. This movement has produced a bow shock, an arc-like structure of compressed interstellar gas, spanning more than 4 light-years. Measuring the size of red supergiants like Betelgeuse is notoriously challenging. Its diameter isn't constant. Because it's a pulsating star, its outer layers expand and contract, leading to shifts in size and brightness. Add to that the layer of gas and dust ejected from its surface, and the view becomes even murkier. These external shells affect the star's apparent luminosity and size, especially when observed at different wavelengths. In fact, Betelgeuse's measured diameter can vary by as much as 35% depending on the spectral band used. In July 2009, the European Southern Observatory released extraordinary images captured by the Very Large Telescope Interferometer. They revealed a massive gas plume stretching up to 30 astronomical units from the star, roughly the distance from the Sun to Neptune. At least 6 such outbursts have been observed, each offering a clue into how red supergiants lose mass as they approach the end. These findings raise questions about the mysterious internal processes driving mass loss in dying stars. Understanding these eruptions could provide vital insight into the final stages of stellar evolution and help predict when a star like Betelgeuse might finally explode. Thanks to breakthroughs in astronomical imaging and spectroscopy, particularly with interferometry, scientists are now beginning to unravel some of Betelgeuse's enigmas. In 2019, researchers using the Hubble Space Telescope and other observatories discovered that Betelgeuse had ejected a massive portion of its outer shell, triggering a major surface mass ejection. Though our Sun regularly produces coronal mass ejections, Betelgeuse's outburst was thousands of times more energetic, discharging about 400 billion times the mass of a typical solar flare. This eruption likely caused the dimming event observed in October 2019. By mid-February 2020, Betelgeuse had lost nearly 2/3 of its brightness, dropping from magnitude 0.5 to 1.7. By February 17, its luminosity had stabilized, and shortly afterward, the dimming ceased altogether. Interestingly, this event did not correspond with any significant drop in infrared output, suggesting the core remained stable. One well-supported theory proposes that the dramatic dimming was due to a massive dust cloud expelled during one of the star's surface eruptions. This dust temporarily blocked light from reaching Earth, not unlike a celestial curtain drawn across the stage before a performance. When Betelgeuse does finally explode, it will be a sight unlike anything humanity has ever witnessed. Though it lies approximately 640 light-years away, the supernova will be visible from Earth, possibly outshining the full moon and even appearing during the daytime for weeks or months. Despite how dramatic this may sound, Betelgeuse's distance from Earth ensures we're in no danger. No harmful radiation or shockwaves will reach our planet. Instead, we'll be treated to one of the most spectacular astronomical events in modern history, a cosmic fireworks show of epic proportions. This event will offer an unparalleled scientific opportunity. Because Betelgeuse is so close, in astronomical terms, scientists will be able to study its explosion in detail, tracking every phase from detonation to aftermath. Most observed supernovae occur in distant galaxies, making it hard to gather precise data. Betelgeuse's relative proximity will change that. Instruments like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based arrays such as the VLT and ALMA continue to monitor Betelgeuse. They analyze convection patterns, surface disturbances, and mass ejections that hint at the star's instability. Detectors like LIGO, Virgo, and IceCube will also be on high alert. When Betelgeuse explodes, it may emit neutrinos and gravitational waves, ripples in space-time that could give scientists unprecedented insight into the laws of physics. Ultimately, Betelgeuse is more than just a bright point in the sky. It's a ticking cosmic clock. Its eventual supernova will deepen our understanding of the life and death of stars, enrich our knowledge of cosmic chemistry, and help us unravel the mysteries of our universe. Massive stars like Betelgeuse forge the heavy elements, iron, carbon, gold, that become the building blocks of new stars, planets, and possibly even life. When they die, they scatter these elements across space, enriching the galaxy and enabling new celestial bodies to form. Betelgeuse's future explosion could help us better understand this process in real time. So, we wait. Maybe the star will go supernova tomorrow, or maybe not for 100,000 years. Until then, it remains a fixture in our night sky and a source of endless curiosity for astronomers worldwide. One thing is certain. When it finally happens, the universe will put on a show that no one will forget.